Okay, so today we're going to talk about class diagrams. Now, class diagrams are something that I am a big fan of. They allow you to plan your programs. Now, we're going to be doing this program together for the most part, at least. But this is the way that I want you to see the way I approach creating a large program. You we know that the more you plan ahead, the better things will be. And this is just a simple way to plan using object oriented programming. What I would like to do is make a program that can tell me the area and perimeter of different polygons. Okay? That's my plan. All right, let me put that here so you can kind of see where I'm coming from there. Get rid of that. So program plan. Find perimeter and area of different polygons. And there we go. All right, that's just a simple thing. So, but I'm going to break this down in the smaller chunks, okay? And we're going to be dealing with polygons on a coordinate plane. So the first thing I'm going to think about is, when I have a polygon that I need to work with, it's going to have like points, okay? And those points have coordinates like 3, 7, and this might be like 8, 2, and maybe this is 1, 1, right? And so I'm thinking, what kind of objects do I need to make? Well, I think first off, we need to make an object to describe points. So if we're going to have point objects, we need we need a point making factory. That's a class. So class point. Now that I've decided that I would like to make a class called point, I need to just think about what kind of characteristics a point has. Well, I mean, we could give it color and stuff like that if we wanted to, but how about we just stick with X and Y? Okay? So I'll give it a variable name, and I'll say the X coordinate of the point. And sometimes when I'm doing this, a lot of times I'm just writing this on paper, but sometimes I like to use two different fonts. So I got my Courier New for my code font, and then this is my description. So I like to go here and make that Courier New as well. That's just me being silly, though. All right, now, the other value is Y. All right. So I've got the X coordinate and I've got the Y coordinate. Make sense? I don't really think there's anything else to describe. And that's what goes here. These are my instance variables. This is what I'm using to describe my point. Now I want to think about the different methods that my point could have. Well, it's not really a lot of different methods that I could think of right now. Might be nice to be able to get the distance from one point to another, though, right? But I think I'll just leave that for now. So, no methods. We can come back and do that if we want later. All right, now when I made this triangle, after I made points, I made segments, right? So that means let's make a segment class. Well, what kind of things make up a segment? The segment is made up of endpoints, right? Like if I have a segment from A to B, that defines the segment, the start point and the end point, right? So I'm going to call this A, end point A, and B, end point B. All right, well, let's think about what we could do with a segment now. Well, I think the best thing to do would be to make a method called length. Okay? I'll just call it length. And then the parameters here is just self. There we go. Now, what will this method do? It's just going to return the length of the segment using the distance formula. Sound good? All right, now after I've done that, I'm going to I can make a triangle, I can make a square, I can make all sorts of things. Let's start with a triangle, and then maybe we can generalize this. Triangle. Now the triangle is going to be, it's going to have 3 points, right? But it's also going to have segments, right? So that would be the different segments of our triangle. And then we can do area. Return the area of the triangle. And we can have perimeter. All right. Okay, so the only thing left to do is to code it. But I'll keep this handy as our blueprint. Let's start with point. So I'm going to make a new module, and I'll save it. And I'm going to call this geometry. Now, in order to do things like take a square root, I'm going to need to import the math module. So I'm going to go ahead and import math. Okay? So that allows me to do some things. Okay. Class point. So to set the instance variables that we were discussing, we talked about instance variables of x and y. We need to set those in our constructor, which is called underscore underscore. You need 2 underscores, init underscore underscore. Then we need the word self, and then the variable names x and y. And it's good to give them good variable names there, because if somebody forgets one of them, Python's error will be more meaningful. It'll say expected to be given a value for x, and if you call the x like a, they might be confused which one that is. And then we just simply say self.x. Now that's creating an x that belongs to this point is equal to x. And then self.y is equal to y. And it's a good idea that we run our module routinely, regularly, every time we add to it, and check that it's working the way we expect it. So down here in my interactive shell, since I've run geometry.py, I should be able to create a point. If you haven't run it, this class does not come pre-built, as far as I know, in Python. So We've run it. Now we can create a point 5, 8, p1.x, p1.y. Notice that the p1 is the self. We're used to self.x when we write it up here. That self is representing the p1 itself, the point. And so p1y 8. We've seen stuff just like this in Pygame. When we would have it, we'd make an actor. We'd call the actor, I don't know, like hero, and we'd be like hero.x, or maybe we make a wall.x, wall.y, wall.pop. Somewhere in that code, they must have written self.x. All right, as far as I can tell, the point class is working well. We can, make another point here just to make sure that the values are not like writing over each other. P2x is 0 and P1x is still 5. So it seems to be working the way we want it to work. The next thing I'm going to do is I'm going to create a segment class. Okay? So I'll say def underscore init self xy. Oh, wait, segment. I'm looking at the wrong thing. We're supposed to do A and B for point A and point B. I'm going to call it this. Point A and point B. That looks good to me. So self.point A and self.point B. We could call it A and B or something like that as well, but I just felt that made more sense. Now, we want to be able to measure these segments, so I'm going to do that. I'll say def length, and you don't have to tell it anything. You just say self, because to find the length of a segment, all the information we need is stored in point A and point B. Now we need to do the distance formula. So let me pull that up. The distance formula between 2 points. The first point is x1, y1. The second point is x2, y2. Is x2 minus x1 squared plus y2 minus y1 squared, and then the whole thing is square rooted. Okay? So that's what we need to figure out. There, I think I got it where I can see my formula and my code at the same time. Okay, so I'm going to be taking the square root. Now, we can do this all in one line, or we can do it in batches. So I'm going to say xlen, and I need to subtract the second point minus the first point. So the second x value is point B. So I have to say self dot point B. That gets the point B of myself. I'm talking about I'm a segment. Imagine I'm a segment. I have 2 points. I have my point A and my point B. They're not your point A or point B. They're my point A and point B. So self dot point B minus self dot point A. But I need their x values. So I have to say point B dot x and point A dot x. So I have self meaning myself. What do I want to get from myself? I want to get my point B. Dot. What do I want to get from point B? My x coordinate. Minus self dot point A dot x. Now I'm going to get the y-len. Self dot point B dot y minus self dot point B dot y. Oh, point A. All right. Now that I've got that, I've got both of these things here. both of these things have been computed. There's my xlen, there's my ylen. Now I need to square them and square root and return their square root. So I'm going to say return math.squirt for square root xlen times 2, that means to the second power, plus ylen times 2. And that should do it. And with that, we can test our code. So I'm going to make a segment. So first I have to make a point. So I'm going to say P1 equals point, and I'm going to do 0, 0, and P2, I'm going to do 0, 4, and I'm also going to make a P3, which is 3, 0. All right. So let's make a segment. S1 equals segment. Now a segment requires 2 points. So I'll say P1, P2. All right. Notice that I can find my segment. I can say S1 dot point A dot X. S1, that's my segment. Point A, which was the P1 that I put in, dot X, and you can see that's a 0. I can say S2 dot point B dot Y. I haven't made an S2. Oh, never mind. S1 dot point B dot Y. There we go. Let's find the length of that segment though. Okay? So S1 dot length 4. Right? That's the object there. So S1 dot point A dot X was 0. S1 dot point B dot X was 0. But the Y was 4. So I went, if you look at it on a graph, we started at 0, 0, and all we did was go up 4. That's clearly a length of 4 units. So that works pretty well. All right, I've still got these P2 and P3. Now, I made P2 at 0, 4, and I made P3 at 3, 0. So this should be, if it does this correctly, this should be a length of 5, because this is 3, 4, 5 right triangle. So that's a good idea. Let's try that. So S1, S2 equals segment, and we're going to do P2 to P3. Sure enough. Okay. So there we have it. I think it's working well. All right, now that we've done that, let's see if we can't do some things that are nice about it. What I wanted to talk about next is, it's kind of annoying that when I say S1, it says main dot segment object blah, 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 blah. And if I print it, all it does is print that. It would be nice if we had a better description of our object, I think. So we're actually going to write a new kind of method that's a dunder method. Double under. Underscore, underscore, str, underscore, underscore. Self. So what this is it tells Python what to do when someone tries to string you. So if I say str s1, that's what I get. all it does is give me the memory address in the program, main segment object at that. Well, I would like this to be better. So when they string my point, I want to return a string of parenthesis plus str self.x. So it's going to string my x number, make it a string, plus quote, comma, quote, plus str self.y, plus quote, close parenthesis, quote. Oh, and I don't need this open parenthesis. Sorry about that. So we're going to return that whenever we string ourselves. And you can imagine that if my point is 4, comma 5, it's going to look like parentheses 4, comma, space, 5, close parentheses. Now let's do the segment. So def underscore underscore str. How do I want this to be compared? Well, I think it would be nice if we just listed the 2 points. So I'm going to say return str self.point A to plus 2 str self.point B. Now this is only going to be effective because we wrote the str double under method from point class. So double underscore methods are methods that you can call, but you don't have to. They get called automatically for you when needed. So I've created P1. It's a point object. But if I try and print it, it gives me the nice values now. Because that's what printing automatically calls str of P1. Or you can do this. So saying print, when you say print an object, when you say str an object, when you call dot double under str double under parentheses, all of those will access that method for you and make it 5.2. Whatever. It'll make it nice and pretty. All right, so I got 1 point. Let's make another point. P2. And there we have it. Okay. Now that we've got 2 points, P1 and P2, I can create a segment. And again, the segment is an object, but we can now look at it more pretty. So we just kind of improved our program, and that's going to help us when we debug and work on, things like that, get information. So the string function is a nice one. All right, I think the next thing up for us is to make a triangle. All right, well, our triangle is going to be made up of 3 points. Now, just because we only have 3 parameters doesn't mean that we're stuck with only having 3 instance variables. At this point, I think it would make sense for me to go ahead and create the 3 sides by making 3 segments. So I'll say self.seg AB, and we'll call segment with, and I can either say point A, or now that I've written it, I can say self.point A. Just out of habit, I'm going to go ahead and say self because that would work other places. So self.point A to point B. I'm going to do A to B, B to C. And I'm going to do C to A. Well, I'll call it AC so it doesn't look weird. Okay. Well, I guess I should stick with A. Let's see here. I was like picturing myself going around in a circle, but all right. We've got all three of them created. So let's write a method that will tell us the perimeter of our triangle. So to get the perimeter, we simply need to add all the segment lengths. So I'll say return self.segab.length. That's the length of segment AB. Plus self.segmentBC.length. That's the length of segment BC. Plus self.segmentAC.length. So I've called the dot length method on each of the three segments that belong to myself. And I've added them all up. And now I can return that value. Okay, now that I've done that, we can start working on the area. Now, the area is not going to be as simple. You're probably familiar with the formula for area of a triangle, that area is equal to 1/2 base times height. You're most likely less familiar with what's called Heron's formula. Heron, from Heron of Alexandria. He says that the area of a triangle is equal to the square root of something called S, which I'll explain what that is in a minute. S times S minus side A, S minus side B, S minus side C, where A, B, and C are the side lengths of the three triangles. This gives the area of the triangle. So that's the formula that we'll be using. S is called the semiperimeter. And if you know what a semicircle is, you probably can guess what a semiperimeter is. It's the perimeter of the triangle divided by 2. So we're going to say def area. Well, you notice in that formula we use S a lot for semiperimeter. So S is equal to the perimeter divided by 2. Now, we can't just say this. And we can't say this either. So when you call a method, you call it on an object. And down here, when we would say stuff like, give me the length, seg.length, right? I call the length. Any method has to be called on the object that you're talking about. So I want to call, thinking about writing a formula for the area, I want, when someone calls for the area of the triangle, we need to get the perimeter of that triangle. So I'm calling perimeter on myself. So when you call a method that is in the class you're working on from another method, you call it on self. In the same way that I said self.segment A, I have to say self.perimeter. All right, good. And then we need our 3 lengths. And I'm going to just go ahead and get them like this. Self.segAB.length. Self.segmentBC.length. And C is self.segmentAC.length. So I've now got 4 local variables, S, A, B, and C, that I can use. I'm going to return math.square root of S times S minus A times S minus B times S minus C. And that completes the geometry formula. Oops. Somewhere I done messed up. Oh, I said class triangle self. I got so happy at putting stuff, I put something there. Shouldn't have done that. Sorry about that. You put self everywhere else, though, but you don't put it there. All right, so I'm going to make a triangle. I'm going to say point A is equal to 4, 6. Point B is equal to, let's see here, 8, 6. Point C is equal to 4, 9. So that should be a right triangle with a base of 4 and a height of 3. So the area should be 6. And the perimeter should be 12, I think. So next we need to make a segment. No, I don't. I can just give it, I can make segments if I want. But I can just give my triangle A, B, and C. So I'll just say that. Triangle equals triangle A, B, C. TRI.perimeter. TRI.area. And that's pretty neat. So what I'm going to have you try and do is make the class quadrilateral. When you make a quadrilateral class, you're going to be able to find the area of your quadrilateral by dividing it into 2 triangles when you have to find the area. The perimeter will be, the same way we did with the triangle. You'll just add up all the sides. But let's say I have a quadrilateral. That's A, and we'll take in 4 points this time. That's B. We'll call that C, and, we'll call this over here D. All right, so I tried to make this not look like anything special, okay? It's not like a special trapezoid, or it's not like a parallelogram or a rectangle, right? It's just a general quadrilateral. So we're being given the points, and this could get, I think it's important that we realize that the points have to go around either counterclockwise or clockwise. But one of those ways. You can't say like A, C, and then B, D. It needs to be, in order, okay? So when they give you the quadrilateral, you get these 4 points A, B, and C. When you have to find the area, make a triangle with points A, B, C, and make another triangle with points A, C, D. So what that ends up happening is that you get these 2 triangles, right? Then the area is the area of that triangle plus the area of this triangle. So that's what you're going to do. And then you're going to write, we're going to write some tester main function to test it. All right, so good luck.